Hi guys, this is Vicky, and today we're going to be learning about how to calculate pH at equivalence point for weak base and strong acid when they do not give you the volume of the strong acid that you will be working with, okay? So this is a request that I got from a whole bunch of students that I've been tutoring, and I figured this would be a great review for all of you. So let's get right to it and let's read to determine the pH during the titration is 36.1 milliliters, 0.274 molarity of ammonia. And we know that ammonia is NH3 and this happens to be a weak base. And it reads that the Kb is this, and then we are reacting with 0.274 molarity of HClO4. And they want you to figure out the pH at equivalence. So first thing first, we know that this is going to be a strong acid. And if we were to just quickly review equivalence point is when you have the pH graph. This is 14, this is 7, and if you're starting out with a weak base, you're starting out somewhere down here and you're adding acid, and that is going to be your acid curve. And the inflection point, aka the equivalence point, is going to be somewhere lower, right? Somewhere over here, so it's going to be somewhat acidic. And if you guys remember, equivalence point is when the H plus concentration equals the OH minus concentration. Okay, so understanding this, I think we can get right to it. First thing first, you have to figure out the moles of NH3, because understanding how many moles of NH3 you have, you will know how many moles of strong acid you will have. So moles is calculated by molarity times volume, and that is 0.274 molarity times 0.0361 liters, and I've actually just converted it in my head by moving the decimal points 3 places, because we are dividing it by 1,000, and if you do the calculations you end up with 0.00989 moles of NH3. So understanding that you have that many moles of NH3, you know for a fact that you also need the same exact number of moles of strong acid. And this is going to help us figure out the volume of the acid needed. Okay, so this is the volume of the acid needed, and it's 0.00989 moles, right? And dividing this out by the molarity of the acid, which is 0.274 moles per liter. So literally what I just did was I used this number and I plugged it in down there. And doing this, it gives me the volume that I need to neutralize this, and it happens to be 0.0361 liters of HClO4. Okay, so now we need to be able to calculate the total volume, okay, once both the acid and the bases have been added, and the base contributed 0.0361 liters, and the acid, HClO4, contributed 0.0361 liters, and if you add them all up, you end up with 0.0722 liters. So this is the total volume. And the reason why we need this is because I need to be able to calculate the new molarity of the conjugate acid, which is NH4+, because NH4+ conjugate acid will also contribute to the overall pH, right? So I am going to be using 0.00989 moles, okay, of NH4+, because all of my base up here, right, all of my base up here consumed up the acid here to create ammonium, right? So this is the number that I'm going to be using right there. So all this divided by the total volume, which is 0.0722 liters, gives me the new molarity, and it happens to be 0.137 molarity of the new conjugate acid. Okay, and so I'm going to just put it in a square, box it so that I know what I'm looking at. Now, they gave you the Kb, But in order for you to calculate pH, you need Ka times Kb is equal to Kw. So understanding this formula, we are going to set everything equal to Kb so that we are able to figure out the Ka value, because I need the Ka value to plug it in into the next formula, which I will show you in just a minute. So over here, they told us that the Kb value is 1.8 times 10 to the negative 5, so this was already given. So this is 1.8 times 10 to the negative 5, and all this is going to be equaling Kw, which is 1 times 10 to the negative 14 over Ka, and so my Ka value is going to be 5.556 times 10 to the negative 10. So the formula that we need to use is going to be the calculation of H plus. So H plus is equal to the square root of Ka times the conjugate acid's concentration, which is that. Do you see that? Okay, so now all I have to do is just plug everything in, and that's going to be 5.556 times 10 to the negative 10. NH4 plus was 0.137, so 0.137 molarity. And if I do the calculations, I get the H plus concentration, which ends up being 8.72 times 10 to the negative 6 molarity. Now, can I plug this in into my pH equation? Yes, I can. So all it is just going to be negative log of 8.72 times 10 to the negative 6 molarity, and I end up with 5.06. So this is going to be my pH after I add a strong acid to a weak base and I reach equivalence point. We good? So if you have any other comments, if there are any other questions you want me to answer, to solve, whatever, please comment below and I will get right to it. All right, see you guys later. Bye.